Welcome to the last section and the last outcome in our trig unit. This is 6.5, cosine law. So up to this point, we've talked about sine law, but there are scenarios where sine law just isn't going to cut it. There are scenarios where we have information that don't fit into our sine law rules. So remember, going back to sine law, we were allowed one of two things in our triangles. So we were allowed to have an angle, an opposite side, and an adjacent side, or we were allowed to have two angles and any side. If we are in a scenario where we do not have this setup, we cannot use sine law. And so we need something else to help us out. So case one is when we have the two sides that form an angle. Case two is when we have the three sides and no angles. In both of those scenarios, we cannot use sine law. So what do? Well, we use cosine law instead. So there's three variations of it depending on how things work out. This is our law though. Okay, and you'll notice that the opposite side is always on the other side of the equal sign. So we've got some sort of Pythagorean relationship showing up here, but then we also have to account for our angles because this is not a right triangle, just like with sine law. So we're still working in that realm of not right triangles. Okay, so opposites are on the opposite side of the equal sign. That's how I always remember it. So B is opposite B, C opposite C. Okay, so we can use this under any of the following circumstances. Number one is if we have all three sides, that's this triangle here. Okay, if you're given three sides, then we have A, B, and C. These are just repetitors of our side lengths here, but we do not have an angle. So we'll be able to solve for all three angles using cosine law. The other option is if we have the two sides and the contained angle. So the contained angle is between two known sides. So that's talking about this first triangle that's shown here. We have the side, we have the angle between, and we have the other side. So basically the two sides that form the angle. Okay, so those are our scenarios where we are going to be using cosine law. Okay, you've got two options in terms of actually using cosine law. Option one is you substitute in and then isolate. So this is our plug and chug option. Alternately, you can rearrange your equation and then substitute after. Okay, and so what that would look like is if we're solving for angle A, we would start with a squared equals b squared plus c squared minus 2bc times cosine of angle A. Now remember that little dot represents multiplication. We use it instead of an x because x can be a variable. So if I need to isolate cosine A, I need to follow my order of operations in reverse. So again, that's that idea of we're peeling away the pieces to get to what we want. So our outermost pieces, the last things that would impact this side of the equation are our b squared and our c squared because they are each separate terms. So we can move them onto the other side. So minus b squared minus c squared. Subtract b squared, subtract c squared. So now we've got a squared minus, and we could even put it in brackets, b squared plus c squared. Subtract all of that. Equals negative 2bc cosine A. Well, now all of this is multiplication, so our opposite operation, it's all one term. Our opposite operation to multiplication is division, so we're going to divide by negative 2bc on both sides. And so our final statement is cosine A, and then we get a squared minus b squared plus c squared divided by negative 2bc. If you are going to use this equation, my big kind of emphasis to you is to remember that when we have this division sign underneath all of these terms in the numerator, all of those terms need to be combined almost like they're in their own set of brackets. It's almost like there's a set of brackets implied around all of that before we are allowed to divide. So just as a heads up, because I find that's frequently something that we kind of mess up, and we'll take a squared divided by all this and then subtract. We can't do that. That doesn't work. Also, please note that our angle technically isn't isolated here. In order to be able to isolate a, we would need to get rid of cosine. We need to undo that function, and that is by the inverse function. So that second function cosine button on your calculator is going to come into play. So let's look at our first example. Determine the length of QR to the nearest tenth of a centimeter. Where is QR? QR is right here, also known as side lowercase p. So again, that we're solving for the side opposite our angle. We have our angle contained between our two known sides. This means I'm not using sine law because I don't have another angle to help me out. I don't have a complete ratio. So I need to use cosine law. So I'm going to use the letters that are relevant to this triangle instead of A, B, and C. So this side is Q, and this side is R. Opposites are opposite in the equation, so I'm going to have p squared equals r squared plus q squared minus 2rq times cos of angle p. Now we can plug and chug. So p squared equals 17 squared plus 10 squared minus 2 times 17 times 10 multiplied by the cosine of 31 degrees. Now again, all of this is together. It is all being multiplied. It is all one term. Another frequent mistake is that people will cut it in part here, do all of this with our variables, and then just multiply by cosine at the end. That is not the case. This is all together. Okay, no cutting apart terms. So we're going to get our calculator and we're going to plug and chug. So again, if it helps to keep brackets around this last term to help you remember that we need to treat it as one piece, definitely continue to do that because we don't want to make a mistake. If we were to actually break it apart, like I mentioned, we would end up going 289 plus 100 minus 340. That gives us 49, and then we'd multiply that by cosine of 31, and that would give us 42 as p squared. Okay, in actuality, what it should be is 289 plus 100, and then subtract 340 cosine 31, which gives me 97.563. That's quite a difference, and so we are definitely going to get an incorrect answer if we go this way. So just be careful. We've got p squared is 97, and that's great, but that's not the end of the question. We weren't asked to find the square of a side of a triangle. We were asked to find the side of a triangle. So we need to solve for p. So we take the square root of 97. We get 9.87. It says to the nearest tenth of a centimeter. So we're going to go 9.9 centimeters. That's my answer. And you can label it on your triangle just to make sure that you've gotten it in the right spot. And there we go. That's how you do example 1. Example 2. We know that we're dealing with some triangle KMN, where KM is 16 centimeters, KN is 11 centimeters, and MN is 6 centimeters. So again, I strongly recommend that you draw a picture to start with here, because having that visual just gives you something to refer back to as you're plugging into your equation and making sure that you're putting everything in the right spot, that you truly understand what the question is asking. In this case, it asks us to determine the measure of angle M to the nearest degree. So I'm solving for angle M. Again, we cannot use sine law here because I do not have any angles in my triangle, and sine law requires at least one angle. So I definitely have to use cosine law here. Because I'm solving for angle M, my opposite side is going to be side M. This is N, and this is going to be K. Remember, lowercase represents the side lengths. So again, I like to write my formula out first so that I can try and avoid plugging in things incorrectly, because that usually leads to like missed negatives or multiplying things that are supposed to be adding, or dividing things that we're supposed to be multiplying. Any number of different scenarios can occur if I don't write my equation first, or my formula first rather. So I start with m squared. Remember, opposites are on opposite side of the equation. So m squared equals n squared plus k squared minus 2nk cosine of angle M. Or if you wanted to use the pre-arranged version, you could use this. I'm going to work as if I don't have access to that. I'm going to work as if I have to manipulate all of it. So I really do like to get everything by itself before I plug in. It's just a personal preference, but I'll show you what it looks like if we had those values. So I'm going to start substituting right now. I've got 11 squared for side M equals 16 squared plus 6 squared minus 2 times 16 times 6 cosine of M. Now remember, all of this is all attached. So 11 squared is 121. 16 squared, if I'm not mistaken, is 256, but I'm going to use my calculator. Yeah, 256 plus 36. And you can even multiply all of these together. So 2 times 6 is 12 times 16 is going to give me 192. Oh my goodness. 192 cosine M, but still all of this is attached. So we can simplify this a little further. We've got 121 gives us 292 minus 192 cosine M. Now again, a frequent error I see is someone is going to go, okay, well 292 minus 192 is 100 minus cosine M. Do not do this. This is so wrong. Okay? These pieces are multiplying together, which means they are all part of one term. It's like saying 2x squared. Well, if you had 3 plus 2x squared, would you combine these two? Absolutely not. And so we don't do it here either. Instead, we move that 292, we subtract 292 from both sides, and we get, just a second, negative 171 equals negative 192 cosine M. Now we can deal with this negative 192 that's attached to my cosine. And I do it by dividing because right now it's multiplying. And I can take the sign with it too. I don't need to just move the 192. I get 0.8906. Now I'm going to keep a lot of decimal places during my questions, and that's so that I can be as accurate as I possibly can. But when I get to the final part of my question where I'm answering what I was asked for, I do need to round to the nearest degree. But all of these in-between steps, keep your decimal places. So up to this point, I've got cosine of m equals this value, but that's not m, that's not my angle. I need to get rid of that cosine. And again, that's by doing the inverse cosine of it. And so we've got cos inverse of 0.8906 equals m. And so if I plug that into my calculator, I get 27 degrees. And that'll be my answer. So it looks like a lot of steps, but remember I did this very stepwise. So if you go from 16 squared plus 6 squared to 292, go right ahead. But remember, don't get too carried away and start plugging these values that are attached to cosine in with our squares. Example 3 now gives us a word problem, but we're still using the same principles. But now more than ever, drawing that triangle, drawing that picture is even more important. So a retaining wall is leaning at an angle of 70 degrees to the horizontal. A rigid support is to be placed 5 meters from the base of the wall, and it will be attached to the wall 2.5 meters from its base. Okay, so a retaining wall is something that's holding up something else. When I think of it, I usually think of either water or even my garden. I'll have a retaining wall to hold up the soil to support it if I've got a raised flower bed. And so that wall is leaning. It's not straight, it's coming out. And it is forming an angle of 70 degrees to the horizontal. So not from here, that's vertical, but the horizontal, which is typically the ground. So we've got 70 degrees. This is my wall. So maybe I color it in red because it's a brick wall. I don't know. So I've got my 70-degree wall. I'm going to place a support so that it doesn't fall over, kind of like the Leaning Tower of Pisa. If it was tipping too far, it might fall all the way over. Okay, so to prevent that, we're going to put in a support. It's going to be 5 meters from the base of my wall. So this horizontal distance is going to be 5 meters. And it's going to come up the wall 2.5 meters. So this distance here, let me just get a different color so it's a little bit more visible. This distance here is going to be 2.5 meters. This is a pretty substantial wall, so I'm thinking it's retaining more than just a flower bed. It's 2.5 meters, that's quite tall. It's taller than most of you. So now I've got a picture though. So whatever it's holding back, it is going to be held back in this scenario. So now I have my triangle. Now let's go back to the question. What is it actually asking me for? Determine the length of the support, so length of the support to the nearest tenth of a meter, and the measure of the angle between the support and the wall. Okay, so we're looking at this angle here, not the support in the ground, that would be down here, the support and the wall. So I'm going to call that angle G because it's opposite my ground, which could be represented by the little g. Okay, so with all of that in mind, we've got some work cut out for us. We've got two sides and the contained angle, the angle between them. That means I cannot use my sine law because I only have one angle but not any completed full ratios. So I have to use cosine law. So 70 is opposite L, and that's the side I'm solving for. So I'm going to use L squared equals g squared for ground plus w squared for wall minus 2gw times cosine of angle L. Angle L is down here. Okay, so when I plug in, I'm going to get L squared, because that's what I'm looking for, equals the ground is 5 meters squared plus 2.5 meters up the wall minus 2 times 5 times 2.5 cosine of 70 degrees. And so this is why I choose not A, B, and C like in my original law, but I choose values that reflect the question so that I can keep track of what exactly each of those variables represents. From here, plug and chug. So I get, when I plug all of this into my calculator in the following the correct order of operations or using bed mass, I'm going to get 22.7, but that's the square of my length. I need to find just the length. So we undo squares with square roots, and I get 4.76. Again, to the nearest tenth of a meter means 4.8 meters is my length. So that's part one of what I was asked to find. I was asked to find the length of my support. Solving for G is our next part of the question. We're not done yet. So in order to solve for G, I need to either use cosine law or sine law. And actually, I'm allowed to use either one. So my personal bias, just as a preference, is as much as I can use sine law, I'm going to use it, because cosine law is just kind of a beast of an equation. Even though it's just still plug and chug, it's a lot more steps, and there's a lot more places where we can mess up. So I like using kind of the little bit more simple, little bit less error-prone method in order to solve. So I'm going to solve for G by using my opposite, which is 5, and then I'm going to use my 70 and my L. Now, I know I've been telling you don't use your values that you calculate, but unfortunately in this scenario, no matter what we tried to do, we would not be able to avoid using L. So it doesn't matter which one you choose, L will be involved. And so again, I like the simpler sine law. If you love cosine law, if you're like, this makes sense, man, I love it, go for it, definitely. And skip ahead to where I've solved for it, because you should still get the same answer. I'm going to use sine law. So I want to solve for sine of G. So I'm going to compare with side G. And then my only complete ratio is L, so sine of angle L compared to side length L. Okay, plug and chug, sine G over 5 meters gives me sine of 70 degrees divided by 4.8, multiply by 5. And then I'm going to have to do the inverse of all of this in order to be able to actually solve for G. And I get 78.19, but again, angles we keep to the nearest degree. So I get angle G is 78 degrees, or that is the angle between the wall and the support. There we go. Now I'm done the question. I found both the pieces, the length of the support and the angle between the support and the wall. So you want to go into your workbooks, you want to do some practice questions, definitely do some practice questions. Definitely make sure you're comfortable manipulating that cosine equation. And then you can do your assessment for T3B, that's cosine law, and you're done this unit. So congratulations, keep working and get to it.